So as we continue here in day 2 with working with the square root and today the cube root equations, if we're having any issues, let me know as we're going along. We'll kind of stop and see how things are going. But the biggest thing when we're working with these, and we talked a little bit about that yesterday, is understanding the shifts and what that means about where my graph's going to start. So for instance here, okay, number 8. So I see this +1 and this +3. What does that mean as far as shifts go? And if you have to cheat and look on the front of your packet, do it.
Left one.
Okay, left 1. Because this number in here is always telling me my left or my right, and it's the opposite of what I would think it is because of the x minus h. And up 3 because the value outside my radical tells me my up or down value. Now, there's one other small change in this one, and that's that this one will end up flipping downward because of the negative that's out in front. So I have a little bit of an idea of what's going on. But again, if maybe I haven't looked at it since yesterday, or maybe you're new to it if you didn't see any of this yesterday, what I'm going to do is I'm going to go ahead and I'm going to go double calculator again with this, because depending on which one you're using currently, if you're going the calculator route, let me get these cleared out.
Is it a negative 1 something?
Yeah, if we are going to type this in, let me slide this one over so I can fit them both here, maybe, possibly. Come on, we need everybody to fit. Okay. Ooh, glare. Less glare. Okay. So when I'm typing this in, and I'll type it in on my one on the computer here first, but yeah, I'm going to use the negative, okay, not the minus, but the negative button. It's a shorter. And then I just type in what I want within the parentheses, and I close it, and I do +3. Now, it's a little different on the fancy ones. If you have one of the TI-84 Plus Silvers, it looks a little different. The negative will still be the same. But then once I bring up, oh, now this one's going to do that. What the heck? I got to switch up again. They're watching at home going, what is this goofball doing?
Wait, who's watching?
Because I'm recording this, so if people are looking at it later, they're going, what is he doing? Why did that change? Because it's just the yellow ones that end up having the button where I have to press right. So if you have a yellow one, okay, and you end up needing to press right to get rid of your little radical sign, if you get stuck, let me know. I can help out with that. But I did put that on one of the video ones for yesterday. So we get this put in. We look at the graph. We're like, okay, it flipped where it's opening down now. Okay. And it looks like, if I'm just taking a manual look, that I did go left 1 and up 3. But let's check. So let's see. Let's look at our table. And we talked yesterday about when the error messages start, I know where the start of my graph is now. But here's one more thing I maybe didn't talk about as much yesterday that might be helpful. If I start here, okay, and notice my first point in the chart says -1, 3, I can figure that out before I ever go to the chart, because when I know what my shifts are, my mother graph, or my base graph, always starts at 0, 0. So if I know the shifts, I always know where my first point's going to be, okay, before I ever do anything else. And for most of you, the best plan with this is going to be to basically look at the chart once you get it plugged in and just start working your way down and writing down the numbers that come out clean. And if any ones that fit within the chart, I'll just write those down.
My graph looks weird. I don't know if I graphed it right.
It might be, you might have a window issue. So while I'm going along here, if you go and hit window up at the top, if yours doesn't look like what it does on the screen right now, you're going to want it to look the same, because this is our base graph that we're working with.
No, like when I plotted it, it looks weird. Like on the graph.
Oh, when you actually plotted your points. Okay, well, let's see here. Let's see what's going on.
It looks different than the one on the calculator.
Does it look anything like... Because did you get the same numbers in your chart? Because if you've got the same numbers, remember, X, I'm moving left and right first, I'm moving up and down second. So like when I'm plotting these, like I'd go left 1 and up 3, and I'd put a point. I'd stay at 0 and I'd go up 2. Now this is the one that tends to get people, because they'll tend to, sometimes they want to go right 2 and up.
That's what I did.
And yeah, but see, that's the nice thing about this. Just noticing the fact that something doesn't look right here is good, because then you can look back and go, okay, now what could have gone wrong? And sometimes just flipping my x and y values can do that. But the other nice thing about this is, once I know that first point, whether it's from the chart or my shifts, my domain and range get really easy. Because however this moves, that's how my domain is going to move. If I shift left, my domain turns into negatives. If I shift right, my domain shifts to positives. Because remember what domain is. It's the furthest point left on my graph, which is right here. And the x value right there is -1. Now my range, again, I have to be a little more careful. The 3 does make an impact. My highest point of my graph is at 3. Okay, so that's going to be on the end. But where's the lowest of my graph? Oh, further. Yeah, -infinity. Whenever you have any sort of a graph, and with these you're always going to have an arrow on one end. One end of your range and one end of your domain is always going to be infinity. The question is which one. With domain, it's not hard. It's always going to be the second one. Range is a little trickier. If it flips down, it's going to be the first one. If it goes up, it's going to be the second. But there's always that direct connection between your shifts and your domain and range, and where that starts. Okay? That's what we were doing with the square roots yesterday, kind of plugging them in and playing with them. So as you start to look a little bit further, and we're going to come to the bottom here, we're going to talk about shifts a little more. Okay? If f of x is the original function, and g of x is the translated, shifted function, identify the shifts. Okay, so these parts are the same. What are my 2 shifts going to be? Left 4 and down 3. Okay. Now then we get to 10, and this is something we didn't talk about yesterday. And one of the reasons I put the one up there off the homework yesterday that I did. Remember, something to the 1/2 power and the square root of something are the same thing. So if seeing something to the 1/2 power kind of confuses you with this, you always could plug it in under the radical. Same here. I could rewrite this as 3 times the square root of x minus 1 if I wanted to. Either way, I could punch it into the calculator, but understanding that these are one and the same is critical, because sometimes it may make it easier to look at it this way rather than this way, and I'm not sure. Everybody's different that way. But I look at this and I say, okay, I see the x here. What's this minus 1? What shift is that going to be? Okay, so it's going to be right 1.
Wait, okay, so for number 9, why would you do anything with the 5?
Well, basically they're saying if I started with this graph, and then these are the changes I made, anything that's the same wouldn't have any difference. So it's just the parts that are different that I'm looking at. Now here, the right 1 shift is different, but this time it is different that there's a 3 out front. So that's going to be a stretch of 3. In other words, you might say it gets wider by the 3, but that 3 is going to make a difference because it's going to make my graph take more time to open up or to get wider. But those are the types of translations or shift type things that we're looking at. So whatever's the same, we kind of forget about. But then we're like, ooh, there's 3 things that are different this time. Bless you. What are my shifts on this one? Right 3. Because up 5. And then what's that negative out front do again? It's not going to necessarily stretch it, but it's going to flip it. And again, when I say flip it, I'm going to come back down for just a second here. So those of you that are writing, hang with me. Whenever you have a negative number in front, okay, your graph's going to open downward. It flips over because when it's positive, it opens upward. So whenever you see that negative in front, okay, we're gonna flip what we normally would be looking at there. But those, again, if you know the little details involved, when it comes to the actual graphs, you'll know if what you're doing is looking right or not. And the only difference when we get to the very back here on what's going on, and again, if you understand the base and how everything works, it's going to make life a lot easier. But what we're going to do here is now, ooh, you're in a cubed root. Ooh, cubes. Okay, let's see. Now, if some of you have the capability of keeping a cubed root on your calculator, that's cool. But if you don't, we have a way around this. So instead of using the square root button, we're going to go to the exponent form. So we're going to do x to the 1/3. And again, I'm doing 1/3 because 1 is my exponent on my x, and 3 is the root that I'm using. So if we look at the graph of this is going to be kind of funky. Kind of looks like a snake in some ways. It kind of slithers up and then whoop, and a little dip, and then it goes again. A little bit, except these are all connected. There's no spaces or holes in it. This is called a hyperbola. So when we're graphing, now let's kind of do what we did before. We're not going to see any error messages this time because the graph doesn't stop. It goes forever in both directions. But what I want you to notice is within my -10 to 10 that I see on a normal graph, I'm going to write down the ones that come out as regular whole numbers. And we're going to find that there's going to be a pattern with these again. Because if I'm only writing ones down for now that are nice whole numbers, that aren't decimals, you're going to find something kind of similar to what we had happen yesterday. Because yesterday, remember, we ended up with the numbers 0, 1, 4, and 9. They were all perfect squares. 0, 1, and 8, these aren't squares. They're perfect cubes. But like we mentioned yesterday, if the value underneath is these numbers, it's going to come out nice every time. So let's get these points plotted. So we got a little bit of an idea of what this is going to look like when we normally do them. Kind of get this nice slithering motion. But here's the part that's going to be fun. Domain and range, this is going to become very easy. I have arrows on both ends. So what typically happens when it's arrows on both ends? Lots of infinity. Negative infinity to infinity. Negative infinity to infinity. Easiest domain and range ever. It may shift up and down a little bit, but this is going to continue to grow upward and downward and right and left. So they're just going to go that way. Okay? The shifts, as far as they go, all work the same way. So you're like, okay, let's see. Now, are these shifts going to affect my domain and range like they do with the squares? Not so much. So here, what are my two shifts in number 12?
Right 1 and up 2.
Okay, right 1 and up 2. Now, if you didn't want to go to the calculator, let me show you a little trick here. I do this a lot when I'm graphing them myself. What I'll do is, when there's nothing fancy in front like a number, like a coefficient like 14, if it's just the values, I will very lightly make my original dots from my mother graph or my base graph, because those are kind of easy to remember. And what I'll do is I'll just look at those 5 points, and I'm going to do the shifts for each of them and just connect the dots. So like if I started at my first dot, like I had up for these, I just go right 1 and up 2, and I put a big dot. And I go right 1 and up 2. For each of those 5 dots, I just go right 1 and up 2. Right 1 and up 2. And you get the same curve, it just shifted.
What dots did you start off
the same ones that I started with my base graph up here. The exact same points will always be my base. Oh, 8, 8, -2. -8, -2. -1, -1. 0, 0. 1, 1. And 8, 2. Because again, they're perfect cubes, so those are all my cubes that I could get. And the calculator table would tell me that too. So if I wanted to do it with the shifts that way, just using these original points and then moving them these two shifts, I can. But if that's something you're like, yeah, either remembering the base or remembering how the shifts work is going to confuse me, so can I just kind of stick with the calculator on this? You can, okay? So there's no need for panic here. So here's how I do it. If I'm going to type this in the calculator, now I have more than just x under there. So I'm going to put whatever's supposed to be in my radical in parentheses, in this case the x minus 1. I'm still going to use the 1/3 power, but that plus 2 on the end is a little bit troublesome. So I'm going to put my exponent, my 1/3, and we said how that works because it's exponent over root. We're going to put that up there, then I'm going to put the plus 2. If I put the 1 divided by 3 plus 2 and I don't use the parentheses, the calculator is going to think that's all part of your exponent. We know that's not right. So once I get that typed in, okay, now I want to see if this looks anything like what I'm doing. Looks like the same thing, but shifted up. Well, let's check the chart. And here's where we start to see, all right, let's see where I'm at. Looks like my first dot's at -7, okay? So there's my first dot at -7, 0, just like I got in the chart. So then I go along. Looks like my next one was at 0, 1. 0, 1, okay. And again, if you don't have that, you can just chart these. 1, 2, yep. 2, 3, yep. My last one should be at 9, 4. Sweet.
Do you have to make a chart?
No. If you're one of those that you tend to sometimes make an error when you're graphing because you'll flip things around, I would suggest making the chart just so if you start looking at it, you're like, wait a minute, something doesn't quite look right here, that it's real easy to look at and just say, you know, oh, I flipped those around. Okay, I get it. And go that way. So I always encourage to kind of write it just in case. But if you're good with your graphing on that and you just want to go with looking at the chart in there or shifting, that's fine. It still doesn't change my domain and range, though. Love domain and range with these. Yep. Yeah, when they're cubed roots, that's going to happen every time.
And then can we use like what we did for number 12? So you started with the original ones and then just graph from those back.
Yep.
Do that for all of them?
The only time I get nervous with that, and I'll show you why, is when we get to problems like 14 and 15 when my coefficient changes in front and becomes a number, because then I got to stretch it too. But yeah, as far as 13 goes, if you wanted to take those base numbers that we had in the first one from my mother graph, and you wanted to plot those first, and then just say, okay, now what are my shifts this time? Let's see. Left 4 and down 3. Yeah, the one on the edge is going to be a little tricky here, because I'd go left 4 and down 3. Left 4 and down 3. Oops, got to count 1, 2, 3, 4, 1, 2, 3. And if I just counted my way with those, 1, 2, 3, 2, 3, okay, I can curve it. But again, if you're not comfortable with that, it is absolutely okay to go into the calculator and plug it in. Now again, there's a couple of things to even be careful with here. Make sure what's underneath the radical stays in parentheses. When you make your exponent, your 1/3, make sure it's in parentheses. And then -3. Because then the cool thing is you kind of have an idea of what it should look like. Yeah, that kind of looks right. Let's see here. Let's see if my points ended up the same. Get back to my negatives here. Okay, so there's my negative 12, negative 5. So my next one looks like it'd be at negative 5, 4. Let's see. Nice. Negative 4, negative 3. All right. Negative 3, negative 2. Awesome. My last one should be at 4, negative 1. Okay. But again, if you're just going with the chart and just jotting down the numbers that fit in the graph, that's okay. As long as you can look at these and figure out the shifts and remember your domain and range. And I'm just going to do this on one more because I think we get the idea at this point. It's going to just keep doing the same thing. Now, like I said, this works great. If you want to do the base and the shifts, that works great on a problem like 12 or 13 where it's just up, down, left, right shifts. But what happens if a number's in front? What happens if it turns into negative? Well, then what do I do? Well, let's talk about the shifts first. Then maybe we can figure out how we can make this work. Ooh, I only have one shift this time. What's my one shift in 14? Okay. Is this underneath the radical? Up 1. Okay, left and rights are under the radical. If it's not under the radical, it's an up down. So I think about this for a minute and I'm like, okay, so if my mother graph starting point was at 0, 0, this one should just be up 1 from that. But since I'm a little more leery this time, let's look at the calculator and then see if we can make the shifts like we've been doing. All right, so I got 2.
So would you just take this 2?
Yeah, just the 2 there at the start, and then I'm going to have x to the 1/3, like when I did my mother graph. I don't have to put the x in parentheses. I could, but since there's no left or right shift, it's not really as necessary. And then plus 1. Now some of you may be wondering, well, isn't it going to take the 2 as well? Nope, it's just going to take that x. So let's see what this is going to look like. It should stretch a little more, and it does. Okay, so let's see where our values are this time. I'm going to make my chart here just so we can kind of see how this is going. Maybe we can make some conclusions here. So negative 8, negative 3. Let's start coming back down here. Okay. Negative 1, negative 1. 0, 1. 1, 3. Do I get one more? Yes, 8, 5. Okay. So you're like, okay, so it's the regular numbers like it was before. So how is this all working? Because it's like some of them have moved and some of them really don't. Well, let's see. So negative 8, negative 3. Negative 1, negative 1. 0, 1. 1, 3. And 8, 5. I'm thinking about this sort of like, what would this look like if I'd have had my original points there? And you're like, well, 0 would have just moved up 1. That's true. But for my others, what would have ended up happening is I'd have had to do both. I'd have had to not only move it up 1, but I'd also have to multiply it by 2. So this is one I'm not quite as comfortable doing just with the shifts. Now, if you wanted to do it without a calculator, I still don't think it would be a problem because, well, with my base graph just being the cube root of 8, I'm just going to plug perfect cubes into it. So as long as I know my perfect cubes are, well, 0 works for everything, but 1 and 8, I would just plug those in. Now, that gets a little trickier on 15. So let me show you non-calculator, that's not even a word, not using the calculator, okay?
Catherine, can you show us using it?
Yeah, I'll show you both. On 15, I'll show both. Because I want you to have that flexibility when you're doing these. So here comes the complexity here. What are my shifts? We'll do that first. Then we'll talk.
Left
Left 2 and up 4. Okay. So here's how this is going to work if I'm going non-calculatoring. I notice here I've got x plus 2, and I'm just looking at what's underneath the radical for right now.
Yeah.
So my goal, now it would be great if it would have worked out this way. It would have been great if I could have just plugged those numbers in, because that's the easy part. But I can't. But I can actually turn them into those, and here's how. I'm going to do some little mini equations off to the side here. Now, you probably would do this mentally. Most of you probably wouldn't normally actually write this out like I'm about to, but here's basically what I'm doing. I'm taking what's underneath the radical, and I want it to equal what I have for each of these. Because if I can get each of these to equal these values, whatever number I plug in, they're all going to come out nice. And I'm not going to even have to really worry much about having a calculator. So some of you are like, okay, so what are you actually up to here? Here's my deal. What could I add to 2 to get negative 8? Well, I could solve this like an equation. I'm just going to minus 2. So if I minus the 2, my x value would be, oops, on the screen, Harty, would be negative 10. If I subtracted 2 here, my x value would be negative 3. Okay? And I'm just solving for x in these little mini equations. And again, some of you, if you choose to go this way, you'll get good enough at it that you probably won't even have to do the side work that I'm doing right now. You'll just be like, oh, so I'm basically minusing 2 from every one of the values that I had to start with. I'm doing the shift. I'm like, oh, okay. So once I do that, and I'd plug those numbers in, I'd be like, okay, so negative 10, I'm going to spin this for a second so you can see what I'm doing here. So I'd actually be doing, oh, Harty, negative 10 plus 2 would be negative 8. So I'd go, okay, the cubed root of 8 is negative 2. But there's a negative out here, so I'm going to be careful. So the opposite of negative 2 is 2, plus 4 is 6. Okay. And I'm going to do the mental math with each of these. So I'm like, okay, negative 3 plus 2 is negative 1. The cubed root of negative 1 is still negative 1 plus 4. So it would be 1 plus 4, which is 5. 0, I love 0. Because it makes things wonderful. So if I plug in the negative 2, it makes it 0. So that'd just be 4. And I would keep doing these little side work things. So if I plug in the negative 1 there, negative 1 plus 2, cubed root of 1 would be 1, but it'd be negative 1 plus 4, which would be 3. And then finally, my last one, I'd plug the 6 in. 6 plus 2 would make it the cubed root of 8, which is 2, but the negative's there, and I get my 2. So if I'm going on the calculator, I could do the exact same thing that I've been doing. So I'd go, okay, let me clear this out. I've got my new one here. So I've got, again, this is a negative, not a minus, so I got to use the white one here. And I got stuff in with my x, so I need a parenthesis. So x plus 2, whatever's in my radical. My exponent still needs to be in parentheses, the 1/3. And then I just do the plus 4 on the end. So this is what's under my radical. There's my exponent, and there's anything I've got left. Look at the graph. Okay, it opens downward. That makes sense. It's going to flip. So let's see if we get the same numbers that I got when I plugged in my other ones. Okay, negative 10, I got 6. Good deal. And again, I can just punch this in the calculator. Negative 3, 5. Negative 2, 4. Negative 1, 3. 6, 2. If you don't have a calculator and you plug in numbers and get decimals, that's okay to use. I just like getting you whole numbers so you can know and feel confident that you're doing it right. It's not a matter of, well, if I just took any numbers on here and plotted them, why can't I do that? And you can. But you need to plot enough numbers that you're going to get an accurate graph. And sometimes when people use the decimals, they'll want to use like 3 numbers in a row that are all like 2/10 apart, and their graph looks like a line, and then I'm like, nope, that's not quite going to do it. So again, we just like the flexibility here as far as that goes. Okay? But again, the shifts are the same. We love the domain and range on this. I mean, shoot, can't get much better than the same thing every time. So here's our game plan. So we talked a little about this yesterday. Most of your regular square root functions were at the beginning, and I think they even go to 29. I'm not sure why I circled to 28. But it gets you some graphing practice, and again, the shifts. Then the last ones are the cubed roots, and the worksheet that you picked up. Let me grab this. Okay, so even though those of you that like to keep track of stuff for homework checks, this is all one assignment. So don't think this is going to be 2 separate ones. It's all going to be as together as the 7-5 bookwork on page 334. So if you've done part, kind of just keep going with that part. And then today, just to get you a little more practice, okay, we're just going to sketch the graph. And again, if you want to use the calculator, you can. If you want to use a table, you can. If you just want to plot points and shift, you can. But again, do your domain and range on these. And I will admit, I put one not nice one in, just because. On number 6, you are going to deal with some decimals. So don't think I must be doing something wrong because I'm not getting a bunch of whole numbers. You're not on that one. So on 6, whether you're plugging in values or you're doing the calculator, it's okay. Just use some of the decimals, spread out your points, and just graph them that way. That's absolutely all right.
So this is the work as well?
Yeah, this is a newbie. This would be, so for instance, on homework check 6, this is going to be assignment number 4, the worksheet. Okay, the bookwork that we were starting up yesterday, and I shouldn't call this number 4. I should call this, rewind for a minute. My apologies, I got a little ahead of myself. This would be 3 because the bookwork was homework check 6 number 2. Oops. There we go. All right, I'll get it all on the screen at once. So the bookwork's 2. That'll be 3. And then we'll just kind of go from there. Okay. All right. Now that we've gone crazy with this, is there anything question-wise? Because like I said, your methodology of getting there, as long as you understand what the shifts are, and you can understand how to figure out domain and range, those are the biggies, because the calculator can help us on the rest if it really needs to. Immediate issue.
Domain, X.
Yep. Domain's always my X values left to right. Range is always my Y's up and down. But down to up.